Today on this SQL class, for this SQL class, we're talking about joins and relationships between tables in SQL. So far, we've discussed database, we've discussed tables. You know how to write basic queries in SQL, which is structured query language, and you also know how to manipulate and you also know how to manipulate data in the tables. So today we'll be talking about joins and relationships between tables in SQL. And first of all, let's talk about table relationships. We have three main table relationships, and the first one is one-to-one. In one-to-one table relationship, each record in table A corresponds to one record in table B. And here we have two tables. We have table A and table B. For example, let's say table A contains information about citizen. As you can see, we have citizen ID and their full name. And table B contains information about the citizen ID and their ID number. So each record in table A, that is each citizen in this citizen table, must have a record in this table B, that is the ID number. That is, each citizen is permitted, each citizen must have one ID number. As you can see here, we have David Johnson with citizen ID 1, and on table B we have citizen ID 1, which is what you can use to reference this second table, and we can see the ID number of David Johnson. We also have Omoni Yester, which citizen ID is 2, and on the second table here we also have the citizen ID 2 and the ID number. Same thing for Alabi Michael. He has records in table A and he also has his record in table B. He has just one ID card, just one ID number. No citizen in table A record is repeated twice in table B because each citizen only has one ID number. No citizen is permitted to have two ID number because that's like a unique identifier. So this is a perfect example of a one-to-one table relationship where each record in a table corresponds to one record in the other table. Another example of one-to-one relationship is a student and their matric number. In a school setting, each student is permitted to have one matric number because that is like your identifier in school. So let's say we have two tables, a table for students and another table that keeps the students' records and their matric number. No student is going to appear twice with two different matric number because each record in the student table will correspond to one record in the matric number table. So one student for one matric number. That's an example of one-to-one table relationship. Now the second table relationship we have is one-to-many. That is one-to-many table relationship. So one record in table A will relate to multiple records in table B. So we have a table A that contains a customer. We have table A which contains customer's name, and we have table B that contains information about orders. So customer ID in the table A, we can see David. David is the first customer and he has a customer ID of 1. We also have Esther as a customer and she has customer ID 2. We also have Michael as a customer and he has customer ID 3. And on the second table we have customer ID, order ID and their products. And we can see here customer ID 1 is David. That means David purchased a laptop. That is the product he purchased. That is why it's showing on the other table. We also have Esther with customer ID 2. We can see customer ID 2 on table B now, and she purchased a phone. We also have Michael and customer ID 3, and we can see that he purchased a table on the other table. But one is repeated twice. Customer ID 1 is repeated twice, and that is David. That means David bought a laptop and he also bought a keyboard. So this is a one-to-many relationship. one record in table A relates to multiple records in table B. That is David is a customer and he was able to place two orders. But one thing we should take note of is that each order will only belong to one customer. That's why we also have order ID. This order ID is like a unique identifier that we're using to identify each orders. So even though David bought a laptop and a keyboard, the keyboard ID is 103 and the laptop ID is 101, but the customer ID is the same. So this order with the order ID 1 belongs to only David, and 103 with the other ID 103 belongs to only David too. So a customer is able to place many orders in a one-to-many table relationship. That is, one record in the first table can relate to multiple records in the second table, like this customer and order table we just examined. So David was able to place two orders, but one order will only belong to one person. We can have two laptops as a product in this table, but the order ID would be different. So that is what makes the order special. That is what makes it different. That's what makes the two order different. The order ID will make it different. But since the customer ID is the same, that means it's the same customer that purchased different products. Now, the third table relationship we'll be examining is a many-to-many table relationship. That is when records in table A relate to multiple records in table B and vice versa. So we have an example here. We have table A and we have table B here. And table A contains information about two students. We have the student's ID and the name. We have John and Mary with their student's ID here. And in the second table, the table B, we have course is a course table. It shows the course ID and the title of the course. That we have web development and UI UX design. For these two tables, unlike the previous table we examined here in one-to-many relationship, we can see that customer ID was common between the two tables and we're able to link them together. But in this many-to-many table relationship, we have student ID in table A and we have course ID in table B. We also have name here and we also have title here. But nothing is really common between these two. That is why there is a linking table here. And this linking table brings together the two ID, and we have 112, 101, 102, 102 here. So in many-to-many table relationship, records in table A will relate to multiple records in table B, and records in table B can also relate to multiple records in table A, vice versa. So John here in this first table with student ID 1 is able to take a course 101, that is web development, and that same John is taking a the course ID 102, and that is UI UX design. So John is taking multiple courses. He's taking two courses, and that is 101 and 102, and that is web development and UI UX design. And we also have Mary, a student here with student ID 2. In the linking table, student ID 2 is corresponding to course ID 102. That is, Mary is taking UI UX design course also. As you can see, John is taking two courses. Mary is taking, why UI UX design is a course on its own, and UI UX design is really contains two students are taking that course. That is, records in the students table in table A relates to multiple records. That is John. John is taking two courses, web development and UI UX design. And in UI UX design course, we have two students that are also taking it again. That is John and Mary. They correspond to each other, vice versa. Students can enroll in many courses, and each course can have many students. Just like UI UX design, the course has two students based on this table. So before we move to joins, I would want you to take a look at this table again. In one-to-one table, we have two tables here. We have table A and table B we have citizen ID full name in table A, and we have card ID, citizen ID, and ID number in table B. Before we go to joins, I would want to say something. I want to chip in something. If you want to join two tables together in SQL, a column there must be a column there must be a column that is common between the two tables. Yes, there must be a column that is common between the two tables. For example, these two tables we can see right here, this column we can say citizen ID is common between the two tables, and they store the same type of information. You can see 1 2 3 here, you can see 1 2 3 here. So it will be easy to join these two tables together since they both have citizen ID. And in one-to-many table, we have two tables here. We can see customer ID name. We can also see order ID, customer ID, and products. These two tables, we can say what we can use to link them together and join them together is the customer ID. That is like the primary key. We have 1 2 3 here, we have 1 2 1 3 here. They contain almost the same type of information, and that's customer ID. That's the column that is common between the two tables. But in many to many table relationship, based on this example, we have student ID name, we have course ID and title here, and this linking table that serves as the third table, the table C, is what is actually storing the student ID column and the course ID column. If not for this linking table, it would be somehow difficult to join table A and table B together, where you have student ID name, course ID, and title. There's basically nothing that is common between the two tables. But now that we have this linking table, we can say, oh, student ID is here, student ID is here, and course ID is here, it is here too. So it should be easier to join them together. So now let's go into joins. SQL joins. What is joins? Joins are used to retrieve data from two or more related tables based on a related column. Like I said earlier, a related column, that is when there is a column that is common between two tables. So when you want to retrieve data from a table, for example, this table now, they are just separate. You have name, you have the course also in another table. But let's say you want to retrieve the name and the course together. You want it to show in one table, in a single table. You want to be able to see the student's name and the course they are taking. You can use joins for that, to join them together. And we have four main types of SQL joins that we'll be considering for this class. We have inner join, left join, right join, and full join. We can see a Venn diagram on this right hand side. We have left join. The shaded parts in this Venn diagram shows the data the join is going to retrieve for you. So let's say you have two tables, a left table, table A, and a right table, table B. If you plan on joining these two tables together using left join is going to retrieve the shaded part. As you can see from this image, from this diagram, we can see the left table is being shaded, and also what is common between the left table and the right table is shaded. So the left join is going to retrieve all information in your left table and what is common between the two tables, that is table A and table B. It is going to retrieve those data for you. If you use right join to join two tables together, it is going to retrieve all data found in the right table and also what is common between the two tables. If we use inner join, it is only going to retrieve what is common between the two tables, matching records, matching data between the two tables. And if we use full join, it's going to bring the whole table together, both what is common and what is not on both tables. It's going to bring it together to form one complete table. Let's talk more on the four types of join. So starting with inner join returns only rows where there is a match in both tables. Let's go back to the Venn diagram. This is inner join. As you can see, inner join returns only where there is a match. It returns only what is found common between the two tables, between the left table and the right table. As we can see, So we have these two tables here, and let's work with them in our PostgreSQL. So this is my PG admin, and let's practice what let's practice the four types of join to understand the differences between them, starting with inner join. So I believe you should all know how to create a database by now. So you create a table. Inner join deals with joining two tables together. That's what we want to do. So we have two tables already. So now let's create these tables in our PostgreSQL so we'll be able to join them together. And but for me, I have the tables created already, so I'll just import them into my PostgreSQL and work with it. But I believe by now you should all know how to create a table and insert values into the table. So I'll go to my query to under tables in my database, and I would create a table. Create table. The table, as you can see, it has customer ID and customer name. So I will name my table customer. Create table customer. Now, what are the columns that are found in my table? We have customer ID and customer name. So customer ID, and that is integer data type, and we also have customer name. Customer name is voucher. So now let me run this. Okay, query returned successfully. So I've successfully created my table. Now let's see the table I created. Okay, we have the two columns created successfully, but there is no data in this table yet. So I'll be importing my data that I've created in Excel, the small data set I have. I'll be importing it into my table. So that is my customers table. Select OK. Okay, we have successfully imported it. So now let me run the table again and see what I have. Alright, you can see we have the table here now. We have customer ID and customer's name here, and that is exactly the table that is here. 1 2 3 4 Alice, Bob, Charlie and Diana. I have the table already. Now let me save this file as customer SQL file. Save. Alright, so now let me open another query for orders. So let me create an orders table. So create table. Let me create an orders table. So we have three columns: order ID, customer ID and products. That is orders ID for integer. We have three columns: order ID, customer ID and products. That is order ID. We have products for integer. We also have customer ID. So let's run this, and we have products. Okay, the table has been created successfully, and let's check what we just created. Let's run this. Select everything from orders. Okay, it has been created. So now I'll import my data. Let me refresh. Then orders. So I click import or export data. Then I'll pick, select where my data set is. I'll pick it and select okay. Alright. Okay. So now let me run this again and see the data inputted. Alright, you can see the order ID, customer ID, and product. Exactly what is right here. Laptop, mouse, keyboard, monitor. Yep. Alright, so now we have our two tables. Now let me save this as the orders. So orders SQL file. Alright. Okay, or orders SQL file. Okay, I don't want this to. Let me just create a new query too, so you don't get confused. Okay, so now in this query too, I'm going to be practicing the joins. So now the first join we talked about was inner join, and we said inner join returns only two rows where there is a match in both tables. It returns only rows where there is a match in both tables. So to say we want to join these two tables together now, it returns only where there is a match. Based on this table, what do you think is common between the two tables? Like, where is there a match in both tables? We have Alice, Bob, Charlie, Diana. We have laptop, mouse, keyboard, monitor. Okay, the customer ID is primary. We have 1, 2, 3, 4. We have 1, 1, 2, 5. So there is no 3 on this second table. There is 3 in this first table. There is no 3 in this second table. There is 4 in this first table. There is no 4 in this second table. Now let's try inner join. So now the query for inner join is select what are the columns you want to show based on these two tables. What are the columns you want to join? You want to see the customer name. For example, let's say we want to see the customer's name and the products. We want to see the customer's name and the products together on one table. So that's the column you are going to specify when you immediately after your select statement. So we want to select the customer name and the products, but the customer's name is on the customers table, so you start with that. You have to write the customers first, then dot customer dot. You are telling it to reference the customer table and look for the customer name there. So customer dot customer underscore name, that is the name of our column. So if you go to the customer table and look for customer's name column, comma, then the second column we want to select is on the orders table. That's orders dot. We are telling it to go to the orders table and look for so column. So the column we are looking for is products. So it's going to go to the orders table and select products. Then from which table do we want, which table is going to be, now after from you have to decide carefully which table do you want to be the left table and which table do you want to be the right table. But this is inner join, so that does not, you won't understand that. Now when we talk about left and right joins, you will understand that better, since inner join is just going to bring out what when there is a match between the two tables. So select it from, let's say, the customers table. Select it from customer, that's the name of our left table. Then inner join with the others table. Okay, inner join with the others table. Then on which condition do you want it to join these two tables together? Then we'll go to on what's the condition we want it to join together. That is the, look at the table again. We have customer ID, we have order ID, we have customer ID again. So the two columns that, what the two columns have in common is the customer ID. That is the column that is common between both tables, the customer ID, since they have the same column name, and also what the column contains is basically the same thing. So that's the condition on which we are joining them together. So it is going to be on, we'll tell it to go to the customers table and pick the customer's ID there. equals to the orders table and pick customers ID there. So what this query is saying now is select these two columns, this column customer name, this column customer name, and also this column products. But we are using this full stop to say, okay, go to the custom, select customer's name from, this dot is like from customers table, and also select products from the orders table, from the orders table. Then once we select these two columns, select these two columns from, we are starting with customer. Customer is like our left table. Select it from customer, inner join, that means we are saying join customers table with orders, but is this type of join we are using, inner join. So we are saying whatever is common between the customer, whatever match it finds between the customers table and the orders table, it should join it using inner join. On this condition, this is the condition we are using to join it. What's the two columns that are common between the two tables? So now let's run this code. All right, once we run this code, as you can see here, we have Alice, Bob, laptop, mouse, keyboard. All right, so you can see better now. We have this is the two tables we joined together. We had customer ID and customer name here, and we had order ID, customer ID, and product here. And merely looking at these two tables without using your SQL join, you know, I said it earlier, we have 1 1 2 here, and we have 1 and 2, but 3 and 4 is on this customer name table, and it is not on this order table, and 5 is on this table, but 5 is not on this table. So you can see now, once we joined it using inner join, this is the this is our results. We have Alice twice, that means Alice purchased laptop and also mouse, and we also have Bob that purchased only a keyboard here. So it is basically printing 1 1 2 for us, because that is the only match it's found between the two tables. There is no customer ID 3, there's customer ID 3 and 4 here, but there is no customer ID 3 and 4 here, and there's customer ID 5 here, but it is not here. That is why there is no record, it's not printing that out, because we used inner join. Inner join only returns, it returns only rows where there is a match in both tables, and that is what we've seen here. And that is what we've seen here. We have the customer name and the products. We have Alice, Bob. We have laptop, mouse, keyboard. So, okay, let me specify. So that is inner join. All right. So let's talk on left join. Alright, so let's talk on left join. Left join returns all the customers and their orders. That is, if there is any order. And mind you, it depends on which table you use for your left join and which table you use for your right join. It depends on which table you use for your left table and which table you use for your right table. Okay, to understand that, let's go back to this inner join. With this, from this inner join SQL query, we can see that this customer, okay, wherever you see immediately after from, you put the table name, maybe table name 1, the first table you want to join, and then the second table you want to join, and what will be in between the first table and the second table you want to join will be the type of join you want to use. So let's say instead of this inner join, let's say you used left join. Okay, let me remove this. Let's say you use left join instead of this inner join here. It is going to join it is going to focus more on your left table. And what is our left table? Because your left join is in between the customer and the order and the orders, your left table is what is on the left hand side of your join. What is on the left hand side of our join? We have customer, and on the right hand side of our join we have orders. So customer is going to give more priority to the customer. That's why I said right here that left join returns all the customers and their orders. That is if there is any order. So what we are expecting now is it's supposed to return all these customers name. We are supposed to see Alice, Bob, Charlie and Diana. And when we used inner join earlier, our result was Alice and Bob. That is Charlie and Diana, they were nowhere to be found when we used inner join. But now that we want to use left join, we are supposed to see records of all the customers and all their orders. And if this customer did not make any order, we are still supposed to see their name there. So let's try that out. It is the same. Okay, all right, let me change it back. Let's rewrite the code. Okay, so for let's join, it is still the same thing. Like I said earlier, select what is the column you want to select. You want to select the customer. On the customers table, we want it to select the customer name, and also on the orders table we want it to select the products. Then from our left table here we want to use customer, then left join orders. On what condition? That is customer id is equals to orders customer id. So let's run this. Okay, all right. So now we can see we have Alice, Bob, Charlie, Diana. We can see we have record from our inner join from earlier. If you remember clearly, our inner join output was just Alice, Bob. Alice appeared twice because that was only the match that was found in between. Now let's go back to this diagram. Okay, this Venn diagram. You know, I said earlier that the left join is going to return what is common, what is found common between the two tables, and also what is on the left table originally. So, and also what is on the left table originally. And go back to this table now. You can see this output now, our results. You can see before, when we used the inner join, the answer only stopped at, I think, after Bob. That was the last value. That was the last row we received. Charlie and Diana was nowhere to be found. But now that we use left join, we can also see Charlie and Diana, even though they purchased no products. That's why there is null there. It's going to replace it as null because there was no product. It found no products. Then when it's matched the two columns, you can see here we have Charlie and Diana here with customer ID 3 and 4. But here 3 and 4 is not found here at all. But there is 5 here. You can see in our output there is no 5 because we used left join. That is why it is not there. So let's say, okay, that because we use left join, that's why it is not there. Now let's go to right join. You should be able to predict what right join is going to do since you already have knowledge of inner join and left join. You can see left join only returns everything on our left table. This is our left table, this is our right table. Left join returns everything on our left table with what is common between the two tables. Now let's say if we use right join, see, right join returns all the orders and the customer name. That is if there is any customer name for that order. That is if any customer has actually purchased that order. So right join is going to give more priority to the right table. that is this order table instead of the customer table. So now let's use right join and see what we have. Sorry, right join. It's still the same query. We'll use select. We start with select. Select what is the column we want to select. We want to select the customer name on the customers table and also the orders on the products and also the products on the orders table. From want to select it from the customer, and we are using right join now, and our right table is orders. Yeah, our right table is orders. Now the condition on which we are joining is on customer sorry on customer id equals to orders dot customer id. Okay, yeah, we're using right join now. You can see on our right hand side is orders. Depends on whatever table you want to put on your left hand side or on your right hand side. On our right table here we have orders. We have orders on our right table. On our right table we have orders, and on our left table we have customers. So it's giving more priority to the orders table. So now what we are supposed to expect is it's supposed to print out, it's supposed to give us all the orders and customer name if there is any customer that purchased the order, but it's giving me priority to the orders. So now let's run this. All right, you can see, let's go back to our orders table here. You can see we have laptop, mouse, keyboard, monitor, and our output using right join we have laptop, mouse, keyboard, monitor, but on the customers table nobody has purchased the monitor. You can see monitor, the customer id is 5, but there is no customer id 5 here. That's why it's printing out the monitor, but the customer's name is null because there is no customer found for that particular product. So that is right join. Right join will only return all information on your right table, that is our orders table, and any match it's found between the orders table and your left table, that is your customers table. That is right join. So let's talk about full join, the last join we'll be considering for this class. Now full join returns all records from both tables, including the nulls where the no match is found. It's going to return all records from both tables, that is the customer table and the orders table, including where there is null. Even though there is no match, it's going to return it. It's like, go back to the Venn diagram. You can see full join returns everything, both your left table, your right table, and whatever is found common between the two tables. So let's go to full join. So seems still the same thing. Select Alright, so when we use full join, as you can see, it gave us everything, including the left table, the right table, and whatever is common between. Look at the two tables, customer table and the product table. Even though 3 and 4 they are not here, and 5 is here but it is not here, you can see we now have Charlie and Diana, even though they did not purchase any products. And we also have monitor, even though there is no customer that purchased the monitor, we also have it here. So food join is like joining everything, whether it finds a match or not, it is going to join it together and it's going to bring out a value. It is going to join it and bring out a value. So let me, I said when you use left join, it depends on which table is your left table, which table is your right table. Based on this, our left table is our customer and our right table is order, because customer is on the left hand side of left join and your orders is on your right hand, is on the right hand side of your join. So let me first of all show you. Okay, this is what it is bringing out originally. This is what we have. We have the Charlie and Diana. It's going to print out all our customers, even though they did not purchase any order, based on our left join that we used before. So now what if we swap customer? What if we make orders our left table and we make customers our right table? Let's run this. Oh, sorry. Customers does not exist. It's customer, not customer. It's customer, not customers. Okay, you can see we used left join. Look at what our output is. We changed orders. We now have orders on the left side and we have customers on the right side. Instead of before, we use customers on our left side and orders on the right side. I know I said when you use left join, it gives more priority to the left table. It prints out everything in your left table and whatever is common in your right table. So if you really understand why, if you understand why the results is now different, even though we are still using left join, why is our answer the same thing as when we used right join? Take a look at the right join again. Look at the product of the result of the right join. Let me run it. You can see it is exactly the same. Why do you think the answer is the same even though I'm using left join here? Why is it giving me the answer I got when I used right join? So that is all about joins. If you have any questions, you can drop it in the comment section. And also, if you have any idea why the answer is the same when we use left join and right join, even after I changed the customer and the orders table, after I changed it, if you know the answer to that, please drop it in the comment section. See you in the next class.